Look at this structure. This is what happens when the chaotic, rapid-fire nature of human communication collides with the inescapable demands of institutional auditing. A fast-moving stream of data is forced into a perfectly aligned, rigid lattice. You might expect to find this level of strict formatting inside a bespoke enterprise software environment. But this structure exists in a place built for casual conversation, a standard WhatsApp group chat. Specifically, this is an artifact for April 16, 2026. It is a message sent by a Dr. Sanjeev containing the tag #PhysioAttent, followed by strict key-value pairs, component, topic, type, and absentee roll numbers. These key-value pairs are not normal human syntax. They represent a pseudo-coded data entry protocol, essentially turning a text box meant for emojis and quick updates into a command line interface. Ad hoc communication apps are intrinsically chaotic environments. Yet, under enough institutional friction, users will spontaneously engineer their own front-end database terminals just to survive the administrative load. The artifact we are looking at is the endpoint of a 16-month longitudinal communication log. It tracks the daily attendance records of an MBBS student cohort within a college's physiology department. When Dr. Bansal created the group in December 2024, the administrative intent was simple: isolate attendance records so faculty would not have to scroll through general department chatter to find them. That simple intent immediately gave way to 16 months of highly variable, unstructured data practices, as different doctors uploaded records in whatever format they found convenient. This creates a fundamental tension between the need for machine-readable data compliance and the tools used to capture it. The faculty are attempting to manage a rigorous academic audit within a platform built for casual, unstructured messaging. By reverse engineering this chat log, we can observe a real-time process of schema evolution. We can watch how human operators systematically engineer strict data capture rules out of sheer necessity. Returning to the beginning of the timeline in late 2024, we see the default behavior of the faculty was entirely manual. Early attendance was tracked by taking smartphone photos of handwritten sign-in sheets and uploading them directly into the chat as JPEG image files. This illustrates dark data. When a JPEG enters a digital workflow, it triggers a parsing failure. The data cannot be automatically audited. The blocked stream reroutes, forcing administrators to manually open, read, and cross-reference hundreds of files, slowing processing speed to an absolute crawl. This heavy administrative friction acts as the first evolutionary pressure on the faculty, forcing them to alter their reporting behavior. Relying on unstructured images in high-stakes environments is unsustainable. As the volume of data grows, the human labor required to manually decode it scales exponentially until the system reaches a breaking point. By mid-2025, the behavioral shift is clear. Faculty stop taking photos and begin typing raw strings of student roll numbers directly into the chat. On the surface, this looks like an upgrade. The attendance data is now in text format, meaning it is technically searchable. But watch this extraction simulation. When a script pulls a raw string of numbers from a chat bubble directly into a blank spreadsheet, there are no column headers or labels to provide context. The log reveals exactly why this is a problem. While the unstated default for most doctors was to list absent students, on December 17th, one doctor posted a list entirely made up of presentees. An automated parsing script cannot read intent. It automatically drops that presentee string right into the absentees column, corrupting the dataset by classifying absent students as present and present students as absent. This is compounded by other daily informalities. Spelling variations in names, missing batch identifiers, and omitted lecture topics all routinely break the tracking scripts. Digitizing text is not a solution on its own. Without a strict shared schema, semi-structured data inevitably corrupts systemic analysis. Informal, semi-structured systems can often survive routine daily operations, but they consistently collapse under the weight of anomalies. The first major stressors to hit the system were collective absences. Whole cohorts executed mass bunks in December 2024 and again in October 2025. This timeline graph shows baseline curriculum volume. The second major stressor introduces sharp vertical spikes, fragmented data points like prolonged medical leaves and remedial classes. These scatter data into dozens of isolated points, creating an auditing nightmare for administrators tracking specific individuals. For the faculty members managing this system, the friction of maintaining accurate records amidst curriculum chaos becomes overwhelming. High-fidelity auditing cannot tolerate a system that breaks during anomalous events. The resulting administrative pain serves as the final catalyst for strict formalization. This brings the timeline back to its endpoint in April 2026 and the arrival of Dr. Sanjeev's Advanced Class Intimation Protocol. Dr. Sanjeev issued a strict copy, paste, edit directive. As this side-by-side layout shows, it functions exactly like formatting rules for API documentation, dictating precisely how the human users must format their input. The protocol mandates the hashtag #PhysioATag tag at the start of every message, establishing a permanent primary key for fast, reliable database querying. But the true efficiency of the protocol lies in a negative constraint. It specifically instructs faculty to edit only the absent line and to leave it marked nil if every student is present. By explicitly locking down the variable, this simple constraint removes the presentee versus absentee ambiguity that ruined the 2025 dataset. The department bypassed the need to deploy expensive learning management software. Instead, they engineered a foolproof data entry algorithm executed entirely by human operators. Why go through all of this effort just to track daily class attendance? The institutional driver is found explicitly at the bottom of the new protocol, the National Medical Commission CBME compliance rules. As this visualization shows, compliance stakes are absolute. Students must hit exact thresholds, 75% in theory, 80% in practical. Error in tracking shifts the burden from an annoyance to a regulatory liability. If incorrectly barred, the institution is held responsible. This offers a clear lesson for data scientists and analysts regarding how people use ad hoc tools. When the stakes are high, the tools must adapt. While ad hoc organizational tools almost always start out as chaotic free-for-alls, operators facing external regulatory pressure will inevitably invent and enforce rigid data schemas. Here, structure acts as the primary mechanism for systemic survival.